Now given this RDF graph, what kind of queries, I mean not necessarily RDF graph, again you can look at it, come back to the previous setting of just looking at graph databases, what kind of queries do you have, what kind of query languages that you have. In the original logic database world, we had Datalog, which for most settings it seemed like a relational data SQL kind of query, but for the recursive reasoning part, which was in Datalog, which was not at that time in SQL. Okay, and this has generated, I don't know, probably 20 or 30 really top class research papers. Okay, and this is just a very underestimate of the papers that have come out, and there is a huge work done on how to do recursive reasoning in Datalogs. Okay, and after that again in XPath setting, which I was talking about, XML Wave, which came into the database world, XPath also resulted in huge number of papers, again for exactly the same kind of problems. Like take the first query, Wikimedia / editions. So what you are saying is start from the root of Wikimedia and look at any reachable node from Wikimedia and look for those nodes which have editions as their type. So locate all of them and return those. So essentially this XPath returns all those paths which start from Wikimedia and end with editions. Okay. Editions is something which you have on Wikipedia, for example, different editions of the same page, right? So that's one annotation, that's a type that you can add to the node. And you can actually have more constraints on it. You can specify the path and you can say I want a specific name property of that node which is down there. That's also. So these are more general database style queries. Once the graph databases, real graph databases came into being, there was a effort called Blueprints, and on top of it a language Gremlin, which is quite popular now for many graph databases. So which is almost, you can look at it as a JDBC for graph traversals. Okay, so you pretty much have reachability queries that you can ask for paths, you can ask for graph structure queries. All of them have same kind of JDBC style. Okay, you have a cursor, you can get the next one without really materializing. So all these are supported in Gremlin interface. But one disadvantage of Gremlin has always been that if you want to merge the relational queries along with the graph traversals, you needed some hacking, right? You need to write your own programs for this. So you essentially think of this as you want to add graph traversal on top of your standard SQL. It requires some extra effort, right? You need to put in different JDBC statements. Similarly, if you want to move from Gremlin into some kind of SQL like querying, then you needed to do this extra programming, which was not all that appreciated by Sparkle world, which is mainly for RDF data, right? So there they said, okay, most of the queries that we focus on in Sparkle, which has a recursive definition, we will not get into that. Okay, Sparkle is a query language, right? That's basically what Sparkle query language. So the focus there was, now given with this RDF graph, most of my queries are going to be query by patterns. So I give you a pattern of the graph that I am interested in, subgraph that I am interested in, okay, and retrieve all instances of this sub pattern in my data set. So this could be extended to have templates of patterns, as in you can have variables saying, okay, I am leaving some things unbounded. Okay, that's one thing that Sparkle, at least the version 1.0, focused on. And now there are extensions which are trying to move more towards the graph traversal support as well. So actually providing the paths and trying to find reachabilities and so on. That's hopefully is going to come through in Sparkle 1.1 and 1.2. People are working on this. So how does a Sparkle query look like? If you go back to the original Dolph Lundgren and Bruce Willis graph, you can ask for a query like this: select question mark name, question mark movie. So which means I want the actor's name and the movies where certain conditions hold. These conditions can be seen as a subgraph conditions, right? So you want this guy to be an action hero that you are interested in, and he should have acted in a movie, and it should, so this movie is what you are looking for and the name that you are looking for. The constraints that you are adding is that this person you are looking at, question mark name, should have worked with someone who was born in Stockholm. So if you look at the RDF graph that we explained, so clearly all you get is Bruce Willis for this. Bruce Willis and all his movies, not just the Expendables, all the movies. That's basically what you are getting out of this. So these are the query languages. Yeah?
All his movies provided the last two conditions are also satisfied, right?
No, last two conditions are largely on just the name. So I'm not providing.
I mean, is it a must that he would have to work with a person and the person has to be born in Stockholm?
Yes.
So only if a set of people are there who have worked with Bruce Willis and have worked in, was born in Stockholm, only those
Exactly.
conditions.
Exactly. So in that's why I said in the previous example, it was only Bruce Willis who was there. But you can add. I mean, if anybody has seen The Expendables, you will know there is a huge list of people that will come out of this, right? Pretty much Sylvester Stallone and Arnold Schwarzenegger, every one of them
Who satisfy all the conditions.
who satisfy all these conditions. So you can find all their movies and their names.
So how is this different from the normal SQL queries that we have?
Not as significantly different, right? So at least when Sparkle started, it seemed like very much like a SQL query, right? But the point is that in SQL, if you look at it from the SQL angle, this is a bunch of joins, huge bunch of joins, and SQL tries to avoid, or at least whenever you are in the world of relational databases, you want to minimize the joins, right? So you come up with strategies for materializing these, and so reuse this. Similar ideas can be applied here, but the key difference is that the kind of predicates that you have, they could be huge in number, which is again not the case in relational databases, right? You typically have, how many tables are there in your database? Not more than probably 200 in the extreme setting, right?
This looks like a SQL query, but suppose
This
you
looks
had
like-
inside the predicate also a question mark.
Yes,
Then that's not there in SQL.
that's not there in SQL, but you can always turn it around and say, okay, I will also model predicates as another column, right?
You have to have a database which stores all possible
Predicates
as
as
a
well.
separate table.
Yes.
And then query that.
And
put
then
in your
get
SQL.
back, yeah.
Right.
So there are some efforts for that kind of thing also. So some kind of, you have these metadata that you have, you can query the metadata, get the table names and then query. So you can do that also. But these are never the preferred model in relational. Yeah. So you are breaking the relational ideas there.
You are directly maintaining the global relation
Yes.
for data.
You are maintaining the universal database and then firing queries on it, right? That's one way of looking at it from the relational world. You don't do all these normalizations, you don't do anything. You just maintain one big, huge universal.
Relation is used to just reduce the search space or storage space,
Yes,
fast query retrieval.
yeah, everything falls apart.
How you maintain such things here? Because
Okay.
it creates it will collect it will contain whole relations in a single data, maybe for either in XML form,
Yes,
whichever you will use to store.
I think you're going to get to that, right? How
yes.
you store this.
So that's the meat of the challenge, right? So if you look at, so whenever you look at these query languages, they don't talk about how they have to be evaluated. So at this point, I have no clue how this Sparkle has to be evaluated. I don't care also. These are declarative, right? I don't really care about it. But you really have to worry these kind of issues, like Should I go for universal relation, which means I have to deal with null values, storage issues, minimizing the search space, whole bunch of things, or should I do some other trick? Should I normalize only in certain cases, not normalize it, right? These are the challenges which you will find if you try directly translating these graph-like queries into relational setting.
Another thing is, if you apply, suppose 3NF, 4NF, then after this level of normalization, you will get very accurate result.
Yes.
Is it possible to get such accurate result here?
Yes.
Because there you will get lot of duplicate
I mean,
results.
see, all these normal forms only help not only the efficiency but also in order to keep the consistency in some sense, right? The same requirements hold here also. In fact, as we will see in couple of slides, one extreme way which you already might have seen in this example RDF graph when I was looking at, you can look at this part, the triple part. So I have Bruce Willis born in Ida Oberstein, the edge can be my table, just triple pattern table. So which you, if you go back to your normal form setting, it's almost like BCNF, right? Where you have just key and value, nothing else. And the predicate is encoded in the table name in relational setting. But now you are explicitly storing it. That's right. That's basically the way in which graphs can be stored.
Basically edge list.
Edge list.
Yeah, edge list with the type of edge.
Exactly.
I have one more question. What
Yeah.
is SPARQL languages, SPARQL queries, what kind of queries are better suited for SPARQL? The ones which are deeper, which in sense, your table A connect to B and then C and then D, or is it B, C, D are all connected to A directly? Which kinds, so what, where, which kind of queries are better suited for SPARQL? Deeper or better?
So that depends on entirely the application. So let's not worry about SPARQL. Let's worry about SQL. Okay, I'm going to.
Okay.
So what kind of queries are better suited for SQL?
And not deeper. Deeper ones are probably.
But that's only because your performance is weak. Suppose if I go for main memory databases which support SQL, probably deeper, whatever is perfectly fine, right? So in the same setting, in the same way, you cannot ask a question whether SPARQL is suited for certain kind of queries, whether your database which really implements SPARQL, is it better suited for this? So that's so in terms of power of the language, SPARQL is no more powerful than SQL. I mean, SQL is already Turing complete, so you cannot get anything more powerful than that. So once you have that, SPARQL is no more powerful. So the reason why you came up with a new language than just reusing SQL is that the ease of use and the way you think, right? You go to the RDF world and you look at it from the relational setting. So the way in which people think is different. So in XML, people thought in trees, while in relational tables, they looked at in tabular format. While in SPARQL, that is in the RDF world, people always look at it as graphs. So it's just the ease of use, not which is more powerful. Everything is equally powerful. It just simplifies your life, right?